Dear students, welcome back to my video coaching. Myself S.N.PATI. My students call me PCM Allrounder because I am teaching physics, chemistry and mathematics for plus 2 science first year, second year and CBSE 11th 12th students since 30 years. Subscribe my channel, watch my video and verify my statements. I am confident that my videos will make your funda clear and increase your answering skill in physics, chemistry and mathematics. Now, today's class.
Students, now we enter into the relation of CBSE 12 or plus 2 science second year. So, if you are not strong in the 11th or first year syllabus, then please watch my videos, relation videos for 11th or plus 2 science first year, then come to this 12th or second year syllabus. In 12th or second year syllabus, the relations is related to those present in 11th or first year syllabus. So please cover those videos, then come to second year or 12th syllabus. The first term of 12th syllabus is binary relation. Binary relation, a very simple word, binary relation. It is a relation from set A to set, that is same set. So, any relation defined on a single set A is called binary relation, and here the relation will be subset of A into A. So, any set A, if R is a subset of A into A, then it is called a binary relation on set A. Now we will discuss types of binary relations. In types of binary relations, first is coming identity relation. Identity relation, a very interesting relation. Listen to the definitions carefully. A relation is called identity relation on set A if every element of set A is related to itself only. Listen students, every element of set A is related to itself only. This only word is very important. So, what is telling? Every element of set A is related to itself only. This clause is very important. Let me write set A is equal to 1, 2, 3. So, identity relation is a relation where elements of set is related to itself only. So, if I will write R is equal to 1, 1, then is it a identity relation? Think. The definition is every element of set A is related to itself only. Basing on this definition, think that if R is equal to 1, 1, is it an identity relation? No, because 1 is related to itself is correct. But in statement it is given every element of set A should be related to itself only. So 1, 1 is not an identity relation. But if I will write every element of set A 1, 1, 2, 2, 3, 3, then it can be identity relation. This is an identity relation. This is not an identity relation on this set A. Because every element of A should be related to itself. 1, 1, 2, 2, 3, 3. This is an identity relation on set A. Write another relation. 1, 1, 2, 2, 3, 3, 1, 2. Is this an identity relation? Look at What is there in definition? Every element of set A should be related to itself. So 1, 1, 2, 2, 3, 3 satisfy that conditions. Now this is extra 1, 2. If extra 1, 2 will be present, then it cannot be an identity relation, because in definition there is every element of set A should be related to itself only. Means no extra element should present. If extra element is present, then it cannot be an identity relation. Okay. So how we will write mathematical and identity relation? Mathematical and identity relation will be R is equal to a set containing the order pair A. Every element should be related to itself such that A belongs to A. Okay. These are the things about identity relation. Look at pilane. Binary relation mane relation on same set. So it must be a subset of A into A. Types of binary relation में first असला identity relation. Identity relation का main point होची set A ऊपर वो identity relation माने every element of set A is related to itself only. So R is equal to 1 1 को चिंता करी identity हब ना नहीं हमको लागू ची identity हब बोली किंतु हब नहीं कहीं ना 1 1 अच्छी सतो 2 2 3 3 नहीं definition रे अच्छी every element of set A should be related to itself. Okay. Then asila another set R is equal to 1 1 2 2 3 3. This is a set, okay, containing all the elements of A related to itself. A set A every element is just relate ହେଇଛି, every element present ଅଛି. So this will be identity relation. Put another relation देखो एटा identity हबनी कारण extra 1 2 अछि definition कहूची every element of set A is related to itself only, so एटा identity हबनी. Okay, and mathematically identity relation को लिखिबा it is a set containing the order pairs A such that A belongs to capital A. Okay, then the second type of relation is reflexive relation. Okay, students, we are thinking or we are discussing different types of binary relation. After identity, now we enter into reflexive relation. So listen to the definition of reflexive relation. A relation R on set A is said to be reflexive if every element of A is related to itself. Okay, so look at the definition. A main clause is every element of set A is related to itself. The only word is absent there. Here, the only word was present. In identity relation, there was only word was present, but in reflexive relation, the only word is absent. Okay, so the definition of reflexive relation is every element of set A should be related to itself. Okay, ध्यान दियो पिलाମାନେ डेफिनेशन को आइडेंटिटी डेफिनेशन जेंति हला रिफ्लेक्सिव डेफिनेशन भी सेंति हला गोटिए वर्ड डिफरेंस आइडेंटिटी रे इट्स ओनली लागि छि रिफ्लेक्सिव रे ओनली लागि आइडेंटिटी रे कहूची एवरी एलिमेंट ऑफ सेट A इज रिलेटेड टू इटसेल्फ ओनली रिफ्लेक्सिव रे कहूची एवरी एलिमेंट ऑफ सेट A इज रिलेटेड टू इटसेल्फ इफ set A is equal to 1 2 3 let us write a relation 1 1. Is it reflexive? Think, is it reflexive? No, because every element of set A has to relate itself. Similarly, write another relation 1 1 2 2 3 3. Is it a reflexive relation? Yes, clearly R2 is equal to 1 1 2 2 3 3 is a reflexive relation because every element of set A is related to itself. Now write another relation 1 1 2 2 3 3 1 3 giving an extra order pair. Just like here we have given the extra order pair 1, 2. Here also an extra order pair 1, 3 is given. Now is it reflexive? Listen carefully. Here it was not identity, but here is it reflexive? Yes. Because in the definition of identity relation, there was the word only. Every element of A should related to itself only, but here there is no word only. So after fulfilling the condition, we can add extra order pairs also. Okay, 1, 1, 2, 2, 3, 3 fulfill the conditions of reflexive. Now if we add some extra things, then also it will be reflexive. If we will add 2, 3, then also it will be reflexive. Okay, come to next example. Next example is 1, 1, 2, 2, 3, 3, 4, 4. Is this a reflexive relation? Think. First of all, this is not a relation because 4 is not present in the given set. So this is not a relation. If not a relation, then can it be reflexive? No. Then another thing is R5 is equal to 5. 5. Now come to the point. Is 5 a reflexive relation or identity relation? Look at. In 5 there is no element, so it cannot fulfill the condition. Every element of set A is related to itself, so 5 is neither identity nor reflexive. Reflexive relation definition, every element of set A should be related to itself. Identity definition सेमती थिला गोटे ओनली वर्ड जोड़ी हितिला एटी से ओनली वर्ड ता नाही तेनु रिफ्लेक्सिव रो कंडीशन फुलफिल कला परे जदि किछ एक्स्ट्रा लिखा जाय तबे ताको रिफ्लेक्सिव आमे कहिबा ओके बट जदि एक्स्ट्रा किछ लिखिले सेरा सेट ए रे प्रेजेंट नाही ताले सेटा रिलेशन ही होबनी तेनु सेटा रिफ्लेक्सिव होबनी and empty set cannot be reflexive and identity कारण identity और reflexive रा main condition होची every element of set A should be related to itself.
Now pause the video and write the note. Now pause the video and write the note.
The present topic of discussion is symmetric relation. What is symmetric relation? Look at, if this is a relation R from set A to set B, then if the relation satisfies this condition, A related to B, double implies B related to A, then the relation is symmetric. Okay students, means if inside the relation AB order pair is present, then it will be symmetric if BA order pair is also present. This is the condition for symmetric relation. A related to B implies B related to A. Means if A and B are two elements, small a belonging to capital A, small b belonging to capital B. If A is related to B with relation R and also B is related to A with same relation, then the relation will be symmetric. Now let us discuss some examples. Okay, so let set A is equal to 1, 2, 3. Let us consider a relation R1 is equal to 1, 2, 2, 1. This is symmetric because AB present, this implies BA also present. If 1, 2 present, then 2A must be present to be symmetric. Similarly, consider another relation R2 is equal to 1, 1, 2, 2. Is it symmetric? Yes. 1, 1 present means 1 is present 2 times. So we consider one as A related to B, other as B related to A. Similarly, 2 present means we can write another 2. If we write another 2, then we get A related to B and B related to A. So this is symmetric. In symmetric relation, the condition all elements are not here. Okay, in symmetric relation, the condition of all elements of set A is not present as it was present in identity and reflexive relation. You know, in identity and reflexive relation, all elements of set A must be present, then only it can be said either identity or reflexive, but for symmetric, that condition is not there. What is the minimum condition or what is the required condition for symmetric? If A be present, then BA must be present, then only it can be symmetric. Okay. Now consider a relation phi. Is it symmetric? Think the relation phi. Is it symmetric? Yes. How? Look at, I have told this is little bit logical. Relation chapter is little bit logical. So look at the logic here.
Consider AB is present in relation set. It will be symmetric if BA also present in relation set. Presence of only AB in relation set does not make it symmetric. What happens if there is no AB in relation set, that is for the relation phi? Clearly, if there is no AB, then condition of presence of BA is not required and it is symmetric. So phi is a symmetric relation. The conclusion is, if AB present, then we will search for presence of BA. If there is no AB, then no necessary to search BA, simply take it symmetric. If AB present, then we will search for BA. If AB, BA both present, then it is symmetric. If there is no AB, no need to search BA, the relation is symmetric. So phi is a symmetric relation.
बुझिपारे पिलाने सिमेट्रिक रिलेशन माने रिलेशन भितरे ए बी जदि प्रेजेंट अछि देन बी ए प्रेजेंट रहिले रिलेशन विल बी सिमेट्रिक. फॉर एग्जांपल 1 2 प्रेजेंट रहिला 2 1 प्रेजेंट रहिला रिलेशन विल सिमेट्रिक. जमिति आइडेंटिटी और रिफ्लेक्सिव रिलेशन रे all elements of set A will present condition ଲାଗିଥିଲା symmetric ପାଇଁ ସେମିତି condition ଲାଗିନି. तो देखो 1 2 2 1 रे ମୁଁ symmetric କହିଦେଲି 1 2 3 all elements of set A present ହେଇଛି କି? So ମନେ ରଖ identity और reflexive relation रे all elements of set A is present, that is a condition, but in symmetric relation ସେମିତି କିଛି condition ନାହିଁ. Now come to phi symmetric relation ହବ କି ନାହିଁ. देखो कंडीशन कहूची यदि ए बी प्रेजेंट तेबे बी ए प्रेजेंट हेले सिमेट्रिक. यदि ए बी प्रेजेंट नाही से कंडीशन का डिस्कशन करिया दरकार नाही, द रिलेशन विल बी सिमेट्रिक. सो फाई इज ए सिमेट्रिक रिलेशन जेहेतु कि ए बी नाही और बी ए कंडीशन को हम खोजी. यदि ए बी थांता तबे बी ए खोजी थांती सिमेट्रिक पाई थांती. ओके स्टूडेंट्स, हियर ए बी इज नॉट प्रेजेंट. If AB was present, then I should search for BA to be symmetric. As AB is not present, so we consider the relation phi is symmetric. Okay. Now look at another some points regarding this symmetric relation. For any symmetric relation, the relation R is equal to its inverse. For example, look at R1 is a symmetric relation 1 2 2 1. If I will write inverse of R1, what we will get? Say 2 1 and 1 2. Okay. If I will write inverse of the relation, what we will get? 2 1 and 1 2. So we get R is equal to R inverse. You write any symmetric relation. Look at, I am writing another relation 2 3 3 2 1 1 for set A. Now is it symmetric? Clearly it is symmetric because 2 3 3 2 are present. If we take 2 3 AB, then this BA. So these two fulfill the symmetry condition. Now come to 1 1. If 1 1 present, then another 1 1 also can be written. So this also fulfills symmetry condition. So the relation is symmetric. Now if you write its inverse, what we are getting? We are getting 3 2 2 3 here 1 1. Clearly R is equal to R inverse. Now come to identity relation. Identity relation is symmetric or not? So recall, what is the identity relation on set A? That is 1 1 2 2 3 3. This is the identity relation on set A. Okay, so clearly this is symmetric. So every identity relation is symmetric. Now come to the universal relation. It is symmetric or not? Universal relation, that is A into A. This is symmetric or not? So let us check universal relation A into A is symmetric or not. Write A into A. So what we are getting A into A? 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. This is A into A or universal relation on set A. Now look at this is symmetric or not. 1 1 for 1 1 the relation is symmetric because you can write 1 1 again. Similarly for 2 2 for 3 3 these fulfill the symmetry condition. Now search for others. 1 2 is present. Here 2 1 is present. So they fulfill the symmetry condition. Here 1 3 is present, 3 1 is present. They fulfill the symmetry condition. Now here 2 3 is present, here 3 2 is present. They fulfill the symmetry condition. So every order pair fulfills the symmetry condition. 1 1 fulfills the symmetry condition with itself. 1 2 fulfill with 2 1. 1 3 fulfill with 3 1. Similarly, every element fulfills the symmetry condition. So universal relation is also a symmetric condition. But the one point is very important. Reflexive relation. Reflexive relation may be symmetric or may not be symmetric. Reflexive relation may be symmetric, may not be symmetric. Okay? How? Look at, write a reflexive relation 1 1 2 2 3 3. This is symmetric. This is a reflexive relation which is also symmetric. Now write another reflexive relation 1 1 2 2 3 3 1 3. This is also a reflexive relation but not symmetric. Okay, so reflexive relation may be symmetric or may not be symmetric. अच्छा पहले मैंने सुना रिलेशन जदि सिमेट्रिक R is equal to R inverse हबो माने रिलेशन और तार इनवर्स सेम हबो. फॉर एग्जांपल गोटे सिमेट्रिक रिलेशन लिखिली एटा क्लियरली सिमेट्रिक 2 3 3 2 सहित सिमेट्रिक फुलफिल कला 1 1 अछि माने आ गोटे 1 1 लिखि कि मो सिमेट्रिक कंडीशन फुलफिल करै परबी. सो दिस इज अ सिमेट्रिक रिलेशन. तार इनवर्स लिखिली इनवर्स लिखिला बेले 2 3 अछि माने 3 2 कली 3 2 अछि माने 2 3 कली 1 1 अछि माने 1 1 कली एंड देखिली इन रिलेशन एंड इट्स इनवर्स आर एक्जेक्टली सिमिलर. Then look at here identity relation का symmetric हबो ना नहीं. सेट A ऊपर identity relation होची एटा क्लियरली एटा symmetric होची. सो identity relation symmetric हबो. सो universal relation बा A into A symmetric होची ना नहीं देखो केमे देखिबा ना every order pair symmetric condition fulfill होची ना नहीं देखिबा. Every order pair if at least one order pair is present which does not obey symmetric condition, then the relation is not symmetric. यदि गोटे भी ऑर्डर पेयर प्रेजेंट अछि जे के सिमेट्रिक कंडीशन ओबे करनी, then it is not symmetric. Look at here, 1 1 निज सहित कंडीशन फुलफिल करिवो, आ गोटे 1 1 लिखिले a b b a प्रेजेंट भले देखौछि, 1 2 2 1 सहित कंडीशन फुलफिल कला, 1 3 3 1 सहित सिमेट्रिक कंडीशन फुलफिल कला, 2 3 3 2 सहित फुलफिल कला, 2 2 निज सहित फुलफिल कला, 3 3 निज सहित सिमेट्रिक कंडीशन फुलफिल कला, एमति every element निज सहित सिमेट्रिक कंडीशन फुलफिल करछन्ती. So this is also a symmetric condition. So identity relation symmetric, universal relation symmetric. But reflexive relation symmetric हे पारे नहीं पारे. This is a reflexive relation जे कि symmetric होची. This is a reflexive relation जे कि symmetric होगी. माने बाबा पिला माने 1 3 लागिले भी this is reflexive. Okay, discussion हिची. So this is a reflexive relation जे symmetric होगी. So reflexive relation may be symmetric or may not be symmetric.
Now pause the video and write the note. Now pause the video and write the note. Now pause the video and write the note.